Howdy. So this part is actually two parts put together. So just a heads up, it's on algorithms and definitions, which are two different sections in the book that we're using currently. So just heads up on that part. There's some changes that I made for these set of notes, nothing really critical, but I want to put the call and value stack in where I can, which is really the first half of the notes, because we're programmers. You know, mathematicians, they don't think about this part, so I use this when I teach recursion and programming languages and intro to programming, stuff like that. I use the call and value stack to help me formulate what the equation or what the overall recursive function is going to be in order to complete a certain task. You're actually going to have that type of question in the book for this discrete math class. Having the call and value stack helps out. So what I'm doing the first thing right off the bat here is going over something that you've probably seen before, and that's piecewise functions in some of your math classes. This is a recursive function. You're going to see your f of x is equal to another call of f of x minus 3. That's where the recursion is, because it's going to have to go back and try f again. So you're going to have some exercises here in a minute when it comes to all of this, but this should look familiar. But let me go through everything that we have here with this particular equation. So with f of 10, you're going to end up having a call, your first call, which is at the bottom of the stack, yes, Q and stack, but that's going to equate to our value stack, which is f of 7. That's the x minus 3, so it's 10 minus 3 is plus 2. Now, why did he even choose that one? We have a base condition that we have to check for things. So as long as x, the current value of x is greater than 1, then we're going to use this equation, well, to try to solve everything out. If x is not greater than 1, then we'll use the x plus 3. So once we get to this portion here, you're probably saying, well, wait a minute, I'm not done yet, and you're absolutely right. There's no solution yet because we need to finish out all of these items here. We still have a call left that we need to tackle, and that's f of 7. Yeah. So f of 7, what's that going to do? Well, 7 is greater than 1, so we're going to call f of 4 plus 2. And notice we're still not done. F of 4 is still hanging in there. We got to do that, take care of that. So now f of 4 is going to call f of 1 plus 2 again. Why am I doing that one? Because 4 is greater than 1. We're not done yet. F of 1. F of 1 is equal to, x plus 3. Why? Is 1 greater than 1? No, it is not. So now I get to use that 1 plus 3, really it was x plus 3, 1 plus 3, and here's where things start helping out here, is that now I have a solution for f of 4, now I have a solution of f of 7, and here comes my overall result for this. That's the important part, is understand that that's what we're really going to be actually doing in the discrete math class a little bit later on as well. In the first section, really, we're covering a lot of that. The author doesn't go over call stack and value stack. It doesn't go over this. Honestly, it's going to make it easier for you in the long run. So what I want you to do, and some of the problems cut off here, I want you to go ahead and try number 1, number 2, and number 3. And then I'm going to show you solutions in back of the notes. So they're not going to show up in this particular video, but they'll come up in the back of the notes. If you have any problems with it or anything of that nature, please let me know, and I'm happy to go over it with you. Just stop by or email me, whatever. So we'll start off with that, with recursion.